Okay, let's continue. Let's continue. We look at predicting spontaneous redox reaction. So now we have intention to predict the redox reaction, whether the metal will resolve or not. Is it the case now is that you have seen electroplating, right? So you put in a metal and a solution there. So this solution got A plus, B negative, and this one maybe is AB, not AB lah, it's a CD element you put inside there. There are two possibilities. Either this metal will dissolve, or there will be composition or deposition on the surface here. Okay, so meaning that you put an metal inside a acid solution. Acid means inside got what? H plus and OH negative, because it's water. So if you have more H plus in the solution, means you have more acidic. If you have more OH, means it's more alkali or base. Right? So if you put this metal inside the solution, right? So it's either two possible physical phenomena you can see. Either you see tiny hole inside the metal, means it corrode, it go and all this metal it break, then become ion and also deposition in the water. Another phenomena might be happen means all the small things here will go and stick on the surface. It's either dissolve or deposition. So now we want to predict based on reduction and oxidation understanding that we have, either plus oxygen or remove or give away electron, or oxidation state number increase. It's the same. It's just that now we go into predicting based on our previous equation. Right? So previous section we already cover like how to arrive at the balanced redox reaction. Then now you look at the left hand side and right hand side of the equation, and then you tell me what happened to the original element. Is it dissolved or not? Okay. Yeah. So we will use this diagram throughout this 7.5 section. So we just memorize lah, or you can just see it as a note for you. So let's say the blue color A become red color A. The small circle here is the oxidation number, or you can say it's the charges, right? So orange A, yellow O here for the A is neutral. It suddenly after the process it become red color with its positive charge. So a neutral element that can become positive charge, what does it mean? It means it give away electron already. Right? It give away, then look at your shorthand notes. It give away means it's having oxidation. Lost electron is having oxidation. So again, still the same, draw the red arrow and blue arrow. So here, A become ion, positive, it is oxidation. B receive means 0, become negative charges or negative ion, means it receive electron. Receive means reduction. Okay, so still the same process, and then there must be a movement of electron, means A electron here will move to B. This is the purple color means, because remember A and B is in the same container. They are in the same container. So the same container means electron must go somewhere. If you lose it, it must go somewhere. If you receive it, it must come from somewhere. Okay. So this is the I forgot whether this one come out in your final or what. You are expected to draw this diagram. to explain in general what is reduction and oxidation by using diagram like this. Yeah. So the format will be like same as your test one. Ask you to explain about crystallization. You still remember in your test one? Something in that kind of format. Okay. So if you understand this one, we go very fast. This one. Okay. And then if you see this one, I think you learned this one before in your SPM. When you learn about some element will give electron and then there is a voltage come out in a battery. I think in the battery chapter in your SPM, right? So this one is inside your tutorial lab sheet, tutorial question there. So on the left, this one you don't need to memorize. If you see this one means you need to answer based on this section format lah. So what I want you to focus is at the middle point here, which is the hydrogen. You see the hydrogen plus 2E, and the arrow here is not one direction. Arrow here is double reaction. It means it's a reversible process. So left to right is a plus. Yeah, H plus and 2E become hydrogen. If it's from the left to right reaction, H receive, right? H receive electron. H receive electron, it become reduction. Means if you look at H plus here, H plus 2H plus 2E from the left to right, this H plus is having reduction. But if the question reverse is ask you H2 become H2 plus, then H2 will become it break away. So H2 plus it become reduction. Okay. So yeah. So so here is just like a competition. When you predict something, there is a position there. It's like a F1 car. You need to line up with the position, right? So you just follow this table. So if you are given magnesium and copper, so you look at this diagram. Magnesium is below the last two elements. Copper is above the magnesium. Okay. So magnesium will have tendency of losing electron that copper. So you see magnesium is minus 2.6 V. Okay, magnesium. So you see here lah, increasing strength, increased strength as a reducing agent. Okay, increasing strength in reducing agent. You can either memorize the green color arrow or the blue color arrow, because it's both of them, they are opposite meaning. Okay, so let's say we remember the blue arrow, means as you go down, you have an increased strength as a reducing agent. Again, reducing agent, it means it's an oxidizing process. You see, agent already means it opposite of reducing. It means oxidation. So as you go down means it's more easier to get oxidation. What is oxidation? Release electron. Break, give away electron. So here, if you're given two elements, you need to tell me which one corrode first or which one eliminate itself first. If you magnesium and copper, magnesium is below copper. So magnesium is more easier to give electron than the copper. Okay. So magnesium is oxidized, copper is reduced. Okay, copper ion means in the solution will reduce. You know, this kind of concept. So what mean by reduce? Reduce means it receive electron. Receive electron 你看呢 you see here, Cu2 plus receive electron means it become neutral. It cannot be neutral already means it become decomposition. You will see something sticking on the, or inside a solution, you see copper drop out. Okay, all right. So you need to write this kind of equation. So Mng Cu2 plus become Mg2 plus and Cu. Okay. So how you write the equation? You just need to read this table. Okay, sometimes the question is very short. They give you a statement, they give you an equation or condition. For example, they give you given two metal inside a solution, like for example this one, they give you something like this and then give you a metal and the solution inside there. Then they ask you to write the redox equation, a spontaneous redox reaction. You're given metal and copper. All right. So you just need to refer to this table. Mg become Ng plus 2 plus. Copper, you go to copper. Copper is 2 plus. It depends on whether it's oxidized or reduced. So Mg is oxidized, so it's given higher priority. So Mg will become Ng2 plus. Cu2 plus because it's reduced, so it become Cu. Yeah. So Mg, because it's oxidized. Oxidized means it break away, give electron. Give electron means you look at this table, you reverse from right to left. Okay, Mg reverse right to left. So you write this equation. Then Cu it reduce. Reduce means receive. So receive means you read from the left to right. So you put left Cu2 plus on the left, Cu on the right. And you see, on the inside table is double arrow, but in the slide here, you see it become forward reaction. Okay, because it's this section it asks you to predict what is the direction of the process. Okay, you see something like this. So sometimes the question will set up something like this, and then it give you like CO2 solution here, and then you put in magnesium strip. Then ask you to predict what actually happened. Either the magnesium strip will, you see hole. See hole means magnesium strip become ion. It's solid become ion. So you'll see tiny hole here. And then the tiny hole, the magnesium solid will break into ion inside this solution. So it depends on the sequence inside the table there. So in this case, magnesium copper will deposit on the magnesium. So this is, I think this one also part of your lab report. Okay. Okay. So this one you read. This one read. It's just that what is important is from this table, you should be able to tell me what actually happened. Either it break away or there's a decomposition happen. You don't need to remember the color. It's just that if you got color will fade away. If the thing, you don't need to tell me the change of color, but you need to tell me like what actually you can see visually, what is expected. Either the metal strip become reduced size, or you see a tiny hole. If you strip, then normally we will use tiny hole, or we call it you have a polarization, we call it. Okay, so this one you read now. So for example, if you put copper solid in the magnesium 2 plus, there will be no reaction happen. Okay, the one on the top diagram here, left hand side, because magnesium is more reactive than the copper. That's why magnesium can become ion and change the color, blue color, and the copper, because copper receive electron, it will become solid. Copper will become solid decomposition. However, if you reverse the sequence, you change the magnesium straight into copper strip, and then you dip inside magnesium 2+ solution. If it's above, like for example, copper is above magnesium in the table, so nothing will happen. So this is a prediction. There will be one question, ask you whether got reaction or not. Sometimes the question is very easy. Your answer is no reaction. There will be no reaction. Then you get marks already. Or your answer like, okay, refer to table of redox reaction. There will be no reaction. Or if you malas sangat, you can just say for that section B, and then you straight away write no reaction. Of course, normally you need to explain. Okay. Can I? If no reaction, you just put a cross there. No reaction. Okay. Again, this table is important. As you go down this table, means it's more reactive. Means it's more easier to let go electron. If you are comparing two elements, you know that magnesium and copper, you put magnesium inside copper, magnesium, you will see reaction. If you put copper on the top inside magnesium solution, nothing will happen. Anything that above the element will not have any reaction. Okay. So this one, this is the expected answer if no reaction. Why is no reaction? Because the element A atom have a greater tendency to lose electron than the element B. This is the statement that we're looking for. This is the standard answer we're looking for. If no reaction. If the reaction also same, you need to tell me why. Because some element have a greater tendency to release electron or to lose electron. This is the keyword to score, the highlighted yellow line, based on this table. Yeah, right, good. Yeah, go very fast, this one. The rest you read if you understand. So that's why some jewelries, they prefer to give you gold jewelries rather than silver. Why? You look at silver. Silver is Ag. Just now I mentioned Ag is gold, right? Sorry, Ag is silver. Ag is silver is here. Ag is further down. So if you put gold and silver together, it depends which one. If you put gold in a silver solution, then something will happen. Whichever is below, they will be react. Right? So for example, ferrum. You put ferrum and Ag. Ag will react. Okay, something like that lah. Jewelries. This is just explain why silver and gold used in the jewelries lah, and not magnesium, not zinc, because they are more easier to get corrode or react. Okay, and you use this one for boat repair also, or maybe some aircraft design also, that exposed to corrosive condition. Mean you will put something that can sacrifice on the vessel, then that part or that screw will corrode first, rather than the body. Means the environment will attack that element first. Okay, so this one you read, You read. Okay, so this is just explanation. Which one is forwards, which one is reverse, So this is example of let's say you put Mn and Ni. So you read from the table, you just copy out. Mn from this table is Mn to Mn2 negative. Ni is Ni2 to 2 negative. Okay. You copy these two down, and then you know that if you have Nn, Ni, which one go oxidation? Which one go oxidation? Mn and Ni. This one also same. If you refer to this table, as you go deeper, stronger tendency to lose electron. Means as you go down more, is more reactive. So you have two elements, Mn and Ni. So of course, Ni will more easier to give electron. So based on our short note here, more easier we give priority first. More easier is oxidation. So you write equation. So if it's oxidation, means it's release electron. And another one, redox, means receive electron. So you change the equation a bit based on the sequence. If you're given two elements, you need to look at it, the position. The further down one is to release electron. Right? So one is forward, one is reverse. Reverse means the reverse means it reverse from the normal activity series of metals. Okay. Then you do like the previous exercise, you balance the equation. Okay. This basically, we just give it another name that involves metals. If you see this kind of metal list or table or voltage, basically it just do the same as what we learned in this morning. You balance the equation, then that equation is called spontaneous reaction. The previous section is called balance equation, balance redox equation. But it involves metal, we call it spontaneous reaction. Okay, there is a difference. The step is actually the same. Okay. So here, if you see predicting spontaneous redox reaction, you see the word spontaneous redox. Normally, you'll see two kind of table. One is this green table, another one is the voltage table. This one. This table and also this table. This table. You see these two table. Or you need to refer to these two green table. Okay. Okay. So another example, if you put Mn and Mg, put Mn and Mg, Mn and Mg. So Mg is above the Mn. So no reaction. Huh? Yeah. It depends on the position. Huh? And it depends on which one is forward, which one is receive. Huh? Forward means it means it receive. Forward, another meaning also mean reduction. Yeah. Forward and reverse. So if in the predicting, you need to tell me which one is forward, which one is reverse. Huh? It means you need to add the blue color bracket in your answer. Yeah. And remember, in your equation, please add another cross in the reaction arrow there. You put a red cross, then say no reaction. Okay. So again, you need to start practicing. If you ask you to predict something or a redox reaction, you need to know element A has a greater tendency than B. You need to know how to write this one. If you see question asks you to predict, you need to write answer. Is it reaction or not? If no reaction, then what have greater tendency than B? If got reaction, then you need to write the same sentence also. There's a reaction happen, or there's a forward reaction happen because what? Because either oxidation or reduction happen, and then element A has greater tendency to be oxidized than something. Yeah. Okay. So this is just an example. Determine whether each redox reaction is spontaneous or not. So whether got reaction or no reaction. Okay, let's look at A. A, you have ferrum and magnesium. So go to this table. Ferrum is here. Ferrum here. Okay. Ferrum. They here. Ferrum and magnesium. Okay. Ferrum and magnesium and give you the equation here already. However, the question give you ferrum first. Ferrum is a forward reaction because ferrum become F2 plus and 2E. Yeah, the question will give you the neutral Fe first. Neutral Fe first. Ferrum, so this one is forward. Means if you follow this table and it chun meet this definition, it's called forward. Then Mg2 plus. Mg2 plus is on the right hand side. So in the question, it's on the left hand side. So it's a reverse reaction. Mg here. Reverse. So ferrum and magnesium. Ferrum and magnesium. Ferrum is below magnesium. So ferrum will go first. It means we give priority. Okay. So ferrum will break into ion. It means that it give electron. Give away electron. Give away electron is oxidation. Okay. So you know that if it's below and another one is above, they got reaction. Then you see second one, B. Fe and Pb2 plus. Fe, Pb is here. So ferrum is here. Pb is here. So the one that below the object, if it below, this one will more reactive than the ferrum, right? But the focus here, so it's a forward reaction we give, but we look focus on the forward reaction first. So this one and Pb, the reactant to the Fe is Pb below here. So this one below means this one more reactive than ferrum. So means no reaction. You know? So the standard answer is like this lah. So you see the element, you copy from the table. A, Fe, you copy from the table. Okay. Okay. So sorry, this one is oxidation. Fe with the reverse half reaction above it. Mg. Mg. Oh, okay. So this one, yeah, I give you the wrong answer just now. This one is straight away you need to read from this table. So you write the half equation. Mg2 plus, you copy from 2 plus, and then you read the table here, plus 2E. It become Mg, and ferrum. Mg2 plus. Ferrum. Yeah, I think it's a bit different, right? The two table, is it different? Ferrum, magnesium. Ferrum and magnesium. Magnesium will. Okay, correct. So I think it's more easier you refer to the arrow table. If you refer to the arrow table, A, ferrum and magnesium 2 plus. If you refer to the arrow table, magnesium is below, ferrum is above, right? You see, magnesium is below than ferrum. It means magnesium is more easier to give electron than ferrum, right? So now in this case, if it's magnesium is more easier to give electron, and you see the magnesium A, 2 plus is already in ion already. You're already in ion. So it's very hard to give electron, give away electron because it's already in ion. Understand? Okay, so what does this mean? So maybe here, here you can determine by this statement. Okay, so here it's just that if it's above, then because magnesium is above, then no spontaneous reaction. A little bit different interpretation from the two table. I prefer the one with arrow. Okay. Yeah. So if you refer to this arrow, this green color table, it means if it's above it, you see, you start what is ion, what is not ion. For in this case, magnesium is ion. So if magnesium ion is above the solid one, then no reaction. Yeah. So here, A, ferrum is solid, magnesium is 2 plus. You look at this one. If the half reaction is above the ferrum, then no reaction, no spontaneous equation. It's the different way of memorizing based on table. Okay, just don't confuse with the two table. This is a bit opposite from the one with arrow. Okay, okay, ferrum Pb. So the charges is Pb. If you focus on the charges, the ion one, if it's below, then you can have reaction. This is just a spontaneous. It means either it's spontaneous or not. If you see the ion, the plus ion is below the solid. For example, ferrum and Pb2 plus. So if the ion is below the ferrum, means there is a reaction. Like A, magnesium is above ferrum, means no reaction. for this table, activity series for metals, if you refer to this table, your interpretation is this. But if you use the arrow oxidation agent, that table with the arrow, then it's the opposite interpretation. Okay, I prefer the one with the voltage one, that one. Okay. Okay. Okay, this one is in your labs. So whether can dissolve or not. Okay, basically if it's in acid, you see whether got H plus or not lah. Okay. So acid dissolve matter by reduction of H plus ion to hydrogen. H plus receive electron, combine with OH, you get water. Right. So this one you read. So if you have a solid, this solid strip, you drop into acid, of course, visually, you know that there will be bubble come out. Right? So zinc will dissolve into zinc ion, and H plus will go into hydrogen. Okay. So this will be the equation. Okay, this one you read. This one you read. So if you see zinc is oxidized from the equation, you should know. What I mean by oxidized? It means it releases electron. This one is in acid. This one is in acid. So whether it is spontaneous or not, so if you look at zinc plus H plus to zinc plus H2, so you compare zinc and H plus. So if you refer to the, it depends on which table you refer. If you refer to the one that activity series metals, that one. So zinc and H plus or not. So here don't have H plus. But if you refer to the arrow, the voltage table, you know that H is 0 volt. And the zinc is below H, right? The zinc is below H. Zinc will give you minus 0.76 volt, right? So means that zinc is more reactive than the hydrogen. Okay. I got hydrogen. Okay. So if got that means that you look at the ion, the positive charge. If the positive charge is ion one is above the element, the solid one, no reaction. If the positive charge, if you use this table, if you see the ion positive charge one is below the solid one, then got reaction. Okay. Okay, so if it has, means it's a spontaneous or non-spontaneous. So another way of memorizing is you look at the charges and the solid metal. If the ion is below, then got electron. If above, no reaction. Okay, the rest you read now. Okay, so again, just to test you, Cu and H plus. Cu and H plus, if you refer to this table, Cu and H plus is above Cu, no reaction. If you refer to this table. Yeah, if you focus on the plus sign, the ion, if it's above, then no reaction. If it's below, then got, if you put in gold, then got reaction. Yeah. Okay, so this is just a summarize. This is summarize. Metal above H2 will dissolve, and metal below H2 will not dissolve. So if you refer to H2, Metal above H2 will dissolve and metal below H2 will not dissolve. What does it mean? It means you still memorizing the. I will not write H lah. Maybe I'll just write A plus lah. A plus and B. B is a solid. You're focusing on the plus signs. All right. So if the plus is above, if the plus, okay, let's just draw. Okay, so this is A. This is B. And maybe I put in another C plus. This is C. So if the A plus is below, then got reaction, right? It's below, ma? Correct. No. Below, correct. It's below, then got reaction. You see, check it out. Correct. Sometimes I'm so confused. Like this case, H plus is below the solid, then got reaction. Okay, so if the plus is below, then got reaction. If the plus is above, then no reaction. Yeah, so this is a shorthand note lah. Okay, this is solid. If you see the plus is below, then got spontaneous, above, then no. Referring to this table, green table. Okay. So what does this sentence, red color sentence means? If the metal, this one, if the metal, like what I wrote on the whiteboard here, if the metal above H2 series dissolve in acid, so means, you know acid is H plus, right? H plus is here. So if the metal above H plus, then got reaction. Okay. And it's below H plus. Below H plus, then no reaction. Based on these shorthand notes here. You put solid in the middle, positive above. Those that can break into positive charges one, if it's below, then got reaction. Above one, cannot. This is how you memorize. So, and there's a one exception rules. Usually I won't ask you, but you maybe see this one in the lab. Means I give you nitric acid. So nitric acid do not apply these rules or do not apply what we learned on some metals. On some metals, this and nitric acid HNO3 might not apply on some metals inside the list. Just for info lah. Just for info. Okay, a quick question: does Cr dissolve in the hydrochloric acid or not? Hydrochloric acid is HCl. You know that you will break into H plus and Cl negative. We are focusing on the H plus. So Cl, solid, right? And it's below. H is where? H is below. If it's below, dissolve or not? Dissolve. Based on this shorthand note here. This is how you predict based on this table. So Cl is solid. So you put your hand there. Hydrochloric acid basically HCl. So you are having H plus inside the solution. H plus is here. So it's below, then reaction will happen. Yeah. So this is how you answer. It will dissolve means there's a spontaneous reaction. Yeah, this is just like prediction, like okay, after this chemistry 2, you know how to predict reaction based on this table. This is important when you go into degree program, you learn about material, especially corrosion chapter. Okay. Ag silver, that's dissolved in hydrochloric acid. So this is solid, right? So put your hand there. If it's above your hand, nothing will happen. Okay. So the rest is just sometimes the question asks you, one question asks you to arrange the sequence of tendency of dissolving from strongest to lowest. How to answer? Let's say I ask you zinc. I give you zinc, and then I give you dissolved one is always below here, right? So I give you 4 solution. Solution with 1, 2, 3, 4, 5 here lah. So as you go lower, then it's more easier to dissolve. Yeah. Okay, the rest I think you read lah. So it's more on the battery. The rest is just battery. So battery basically is what? Oxidation. Battery basically is oxidation because you use the energy. So energy must from somewhere release electron. It's oxidation process. The rest you already know. In battery is called electric current. Right? The rest you read. This one you've seen before already. Zinc in copper and copper in zinc just now. Okay. So you will see this one in your lab, right? Okay. So this section is basically to okay, there's one question in final exam. Ask you to put in positive terminal and negative terminal. You need to set up an experiment by writing. So you tell me which one is positive, which one negative, and then what is the experiment setup? One question. 15 marks or 15 marks or something, or 10 marks, something like that. Okay, so this one you already learned before. It's just that recall on electrochemical cell, right? So what general setup is that you have 2 metals. You have a negative side, which is called anode. We call anode. Positive side is called cathode. So in the exam or test 2, you need to identify which metal become positive charge, which metal become negative, which metal is anode, which metal is cathode. Okay. So and then there is a salt bridge. You need to link with salt bridge. Okay. Salt bridge means you allow the electron to transfer from one container to another one. Basically, salt bridge here is different solution of beaker 1 and beaker 2. Salt bridge. Okay. Okay. So if you are given zinc and copper, just to recap, zinc and copper, again, you refer to the half reaction and the voltage potential that table. If you look at zinc and copper, you look at zinc and copper. Zinc is below copper, right? Correct. If you refer to the arrow, this one with the voltage one. like you see positive 2.87 until it's in the tutorial question 44. Huh? If you look at the arrow and you identify zinc and copper, zinc is below copper, right? Zinc is below copper, right? So when it's below, means it's more tendency to let go electron. It will become negative terminal. Yeah, negative terminal, another word means anode. So go to your diagram, you just need to label negative for the one that below the half reaction and potential chart or table. Another side become positive. Then label positive and label cathode. Yeah, and this is how you do it lah. And then you draw two beaker and then draw a U shape and label the U shape as salt bridge. Standard already. This name is salt bridge. Okay. And some diagram, you need to remove the battery. Do not have battery, sorry. No battery one. If battery, it become electrolysis. Means you pump in current inside the process. Okay. Okay. Then because of zinc, again, because of zinc, negative terminal, right? Zinc is below the chart, so it's more easier to release electron. You again look back at your shorthand note. If it's more easier, it become oxidation. Right, release electron. It become more easier become ion. So even more easier to become ion, you need to write the ion that come out from that rock. You need to write this one. You need to write the 2 zinc plus the ion come out from this rock. If you use zinc, zinc become positive ion. Okay. Then this one, copper, right? So copper, it is a positive charge. Positive charge, normally you will see deposition. You will see something deposit on, it become bigger and bigger, the rock. So the arrow of that also important in the test. You need to tell me what stick to that surface. You need to draw an arrow pointing to the rock. In this case, copper plus. Means positive copper charge go into cathode. Okay, then this one you just follow in the question. Zinc sulfate is on the zinc side. Yeah, zinc sulfate is on the zinc side because you're using zinc rod. Don't write the wrong sequence. Another one, because you use copper, the solution you use is copper sulfate. If you accidentally reverse the wrong solution, nothing will happen. No reaction happen. Okay, so it's important. Then still need to remember the blue arrow, red arrow, but in this case, zinc is because it's below inside the diagram. It's having oxidation. Remember to write oxidation on the left anode side. All right, reduction on the positive terminal. Yeah, I repeat, a few important keyword that when it comes to electrode cell or electrochemical cell. First, positive negative terminal. Negative terminal is called anode. Positive terminal is called cathode. Just label positive negative in the diagram. Then refer to the table, put in the correct metal. The one that below the table, move to the left negative terminal. Then draw the salt bridge. Salt bridge got one salt bridge solution. This one doesn't matter. You just copy from the question. In the question, it will mention what is inside the salt bridge. Then zinc sulfate go to the zinc terminal, copper sulfate go to the copper terminal. The rest you read. Okay. So electrochemical cell, you need to, in other words, if it's able to generate current, they call galvanic cell or battery, or do not use battery in chemical 2 exam. You either you write volcanic cell or galvanic cell. This is the answer for the battery lah, actually. But don't use battery in chemical 2 unless you ask to explain and write essay or something. Okay, the rest you read. The rest you read. This one you see in the lab. Okay. Okay, the rest you read. So this is the observation in the lab later. Zinc will become narrower. If your deposition, you have bigger and bigger, and you see there's a deposition there. Yeah, the rest you read from the slide here. Okay, the rest you read. Okay, another one is you have to know how the electron flow in the cell. So it's easier. You know that anode negative terminal is to give away electron, right? So electron will flow from the negative terminal to positive. Okay, the electron will go through the wire. You use voltmeter again. You need to draw voltmeter. Voltmeter, and you need to show me the electron flow from negative to positive, because negative terminal give away electron. Okay, the rest you read. The answer is there. So this is final exam kind of standard. You see something like this, and then you need to tell me what happened. Okay, so you need to write half equation for negative terminal, half equation for the cathode. This one basically copy from the table, or copy from the large table. You'll see the large table at the last page of your page 16. Page 16 of the one, you just copy from there. Okay. Okay. So if you observe, the step of calculation is basically what we covered this morning. Okay. Half reaction. Then you calculate how many electron and so on. Yeah. So CR, and I. So basically you are balancing the redox reaction. So the rest you read. Okay, I highlight this one because it's important. So if you see especially negative terminal is having positive, half reaction. No, this is just reduction is receiving electron, so it happened at the positive terminal. Basically, you just observe where is the movement of electron flow, and then I tell you where does the reduction process happen. The answer is cathode, positive terminal. Why? Because the electron move from negative terminal to positive terminal. Understand? Yeah. And are not having oxidation. This basically is repeating what we covered 5 minutes ago. Yeah. This two box is important. Go home and try to understand what we're trying to say here. Okay, not okay. Okay. Okay, the rest you just read through. I just read through. Okay. One equation with this 1 volt equal to how many column? This one I think you learned in your circuit theory or something. Okay, I flip to the more important slides. Okay, this are important. What does how many voltage that you can measure in the electrode potential cell? These three, reaction, concentration, temperature. These 3 points, important, this slide. Okay, so magnitude means the light, because it's flowing, so you are seeing the light bulb will be either very high or very low. It's based on these three. Either reaction happen, concentration, and temperature. And in all questions, we assume it happened at 25 degrees C for potential cell. This equation important. Means the potential for reduction, the equation for cell potential, you need to memorize. This one, no choice. You need to write EO cell, means the total cell voltage, means if you put voltmeter and measure the two terminal positive negative, you'll see a reading. This is the reading. Okay, EO cell, this is the answer for this is question 74. 74H. Okay, so this EO cell equal to cathode and anode. You take cathode potential minus anode, means cathode means positive terminal minus anode. So this RED means reduction. RED means reduction. Again, reduction is what? Receiving electron. Okay, we see example. Okay, the rest you read. This equation only important when you study hydrogen fuel cell. Means if you drive EV car or you drive a car with the hydrogen, then this is important. Okay, the rest you read. Okay, now we prove how we get voltage if you put zinc and hydrogen. Means you are having zinc and hydrogen as your fuel cell. So zinc and hydrogen, how you know positive, negative? Again, you refer to the table. Or you can go to the appendix E, the last page. More easier to see. So you try to find zinc in the last page of your tutorial question. Okay, zinc is the last component, minus 7.6, right? Appendix E. Zinc is the last component. We give you voltage E0 minus 0.76, and the hydrogen is 0. Where's 0? Okay, hydrogen is on the left-hand side of the table. Okay, so if you compare voltage, EO means electro voltage. So hydrogen 0, this one is 0, this one is having negative, right? 0 and negative. One is positive, 0 I can consider positive lah. So 0 voltage and minus voltage. So the minus voltage one, the one that below go towards negative direction, they always become negative terminal. They always become negative terminal. Hydrogen positive, because 0 lah, but is can consider higher value. That's why hydrogen become positive terminal, zinc become negative terminal. Okay, then if you measure the cell as 0.6 volt, okay, now how you get 0.6 volt is that you use the equation EO cell equal to ERED cathode minus anode. Cathode is positive charge, so you know that positive charge is hydrogen in the appendix E in your tutorial handout is 0. So you can find the anode voltage. Anode voltage based on here is minus 0.76, which is agree with the appendix E. Yeah. Okay. And if you see cell, and then you see keyword standard condition means they use hydrogen in the process, in the cell. So if the question asks you build a fuel cell, build a galvanic cell under standard condition, it means you need to use hydrogen, and then it will give you one element. Then you know whether positive, negative terminal already. Because hydrogen is 0 volt, dependent on the element based on the voltage here. Okay, the less negative one go to negative terminal, the positive one go to positive terminal. Okay, the rest is simple mathematics. The rest you just read. Okay. Okay, so here, I think this one is quite direct. Important is this, the red color equation. The cell equal to cathode minus anode. So here, you are given potential of zinc and what? Zinc and copper. So you refer to here, appendix E, zinc and copper. Zinc is the far left. Copper, zinc is minus 0.76. Copper got a lot. Copper got 1 positive, 2 positive, 3 positive. This is 2 positive. So 2 positive is positive 0.15. So from here, you know which one is positive, negative. Right, one is positive 0.15. Copper become positive terminal. Right? So you put in the value. Anode is minus. This is need to highlight a bit. Because the general equation is E cell equal to cathode minus anode. However, in anode, the voltage is negative. Remember to carry the negative. So negative become positive. Okay. So your cathode is 0.74. Okay. Important is the red color general equation. The rest is just substitute the value from the appendix E. Or from the question also. Okay. Yeah. The rest is application. Go home and read. Okay, this one you read now. The rest also your homework. Go and read. It's basically about battery. Okay, for battery. Basically, I won't ask you question on battery, but battery is part of your content. So go and read lah. How battery works, how lead battery works. Huh? Fuel cell is your area, I mean the Sarawak focus area. So when you study your degree, no matter which degree program you go, ICATS will focus on fuel cell or anywhere you go lah in Sarawak. If you know how to if you know fuel cell technology, you no need to worry about your job lah. People will come and hunt you for Sarawak. Because in Malaysia, we don't have fuel cell technology. We have someone know to use it, but it's still at the lab scale level. Yeah, so the one that you see on the road is basically assembly from other parts from other country, right? Yeah. Okay, the rest you read lah. So this is the something a bit special about aerospace program, which is how they generate water in the ISS. They only need to bring hydrogen and oxygen fuel tank, and then they generate water inside the space shuttle or the International Space Center. Okay. So because of the fuel cell, you pull in hydrogen and oxygen in the fuel cell, at the same time generate electricity, and the product flow out from the fuel cell is water. So astronaut drink the water. Okay. So in future, currently the fuel cell car is releasing the water to the environment. However, maybe in future, we will recycle the water to cool down the vehicle and something. This is a small YouTube video you can view during your free time. Electrolysis, you read lah. It's basically you put a battery there and force the oxidation reduction process. You reverse the thing. Okay, this one you read. Okay, so with this, we conclude chapter 7.